All right, chat, let me know if today feels too mid for y'all. We're going to try to make this lesson slap and get through it until the point where we're cooking, right? Yeah, on God. All right, so, cool. Thank you for the comment there. I don't know how I'm going to have to watch a Twitch video so I can make, like, shout-outs like that. I don't really want to watch any. All right, so this is what we covered yesterday, and it's not word for word, but if I were to make a note card, which we spoke about either in here or physics or both, this is all of yesterday as condensed as I could possibly make it. Everything that we have here is we have some function, f, and we're transforming it. About halfway through the class, Huggins, when you stepped out, not intentionally, I decided, hey, let's call the new one h, so it's just some transformation. And then we saw that if it's inside the argument and it's x minus c, and remember c is a positive number in a weird sense here, x minus 5 moves left 5. X minus negative 2 turns into x plus c, so it'd be x plus 2 in that situation. Now we move the opposite direction. Okay, these are all what are these ones called? They're all rigid, first of all, but these four specifically are known as what? Translation or shift. Either one of those I'm fine with. And then I think, correct me if I'm wrong, we looked at our reflections as well. Okay, if hypothetically, and you don't need to write this down yet because I have several problems and at least a conversation about this. If I give us two functions, let's just pick an ugly one for no particular reason, and don't write it down, I just want to talk about it. If we had f of x were the function, let's say, x squared plus x. Okay, and I wanted to make a transformation that was reflected and shifted right. Let's say right 1 unit. What would happen here? It'd be x plus 1 squared plus x plus 1. Are you guys okay with that idea? This would shift me right 1 unit. Because, sorry, right or left? Left 1 unit. I'm sorry, that was my mistake. Now, if I wanted to reflect, I have to do this, yeah? Negative in front, which means all of this would become negative. Now, maybe in this situation it wouldn't really matter, but I am dying to know, from your point of view, what happens first. For my graph, do I first shift it left 1 unit and then reflect? Or do I reflect it and then shift it? And I wish I had like a tangible parabola to hold because it would help to make sense and play with these things. But does it matter in that situation if I have a parabola and I shift it and then reflect it? Or if I have a parabola and I reflect it and then shift it, would it still work? Maybe it doesn't matter in that situation. Now, what if, however, I wanted this to happen and my original graph has been moved up 5 units. Now all of a sudden, if I'm going to reflect, does it matter if I do it before or after? Because there's a huge difference between, and I'm just going to draw like, let's say I've taken a parabola and I've moved it up here, and then I reflect. It winds up down here, right? Whereas if I first move it to the right, if I move it to the right, it would wind up there. And then if it reflected, it would wind up here. And my plus 5 would move me up. And I get two different graphs that essentially say the same thing, speaking-wise. Do you guys get what I'm saying there? If we don't translate for, like, there's an order of operations that must happen. And my hope today is I think I know the answer. Never once have I seen it explicitly written anywhere. And I know that it comes up not only in my class, but if y'all had Jarvis, I imagine at some point you were talking about transforming functions, something like this, a times b to the power of x minus h, or something like this. And then the order of which stuff happens, it gets weird, and it's strange to think about. It is weird. It is strange to think about it. We're going to see if we can't figure it out today. Okay. When I say the word rigid, though, what do you think of? If something is rigid, you might think like the ridge of a mountain is what oftentimes I get. Not at all where my mind goes. If you want a picture frame and it's rigid, am I going to be able to take it and make that rectangle into, I don't know, a parallelogram like this? No, because it's rigid. It's stuck in place. My shape right now, if I'm rigid, I can't change the shape itself. Have I changed the shape yet? Have I changed the shape yet? What have I changed in those situations? Position, location, whatever you want to word with it. So, I believe yesterday at the end of class, we wrote down something. I don't know if you did or not. But everything that we looked at initially shifting graphs or translating and reflecting our rigid transformations. Did we write the other side? Did we write anything else? Good. Okay. So our focus today is on non-rigid transforms. Now, all those first ones that we've done never touched the shape of it. They're all the exact same shape. Here I am. I want to change shape. What could I do? Okay, so this is going to be, I wish, real bad. I'm going to make a tangible item for us so that we can play with this for next year, I guess, rather. But check it out. You say get smaller. What do you mean by that? Okay, so this is going to be a weird idea, and I don't know, my arms aren't particularly stretchy. But will somebody, Sean, stand up here real quick with me? Do me a favor. Okay. I have two options, and you're just going to grab my arms, just so you know. Okay, Sean's going to change the shape of my parabola, which I'm still kind of a parabola, okay? I'm going to try to crunch in a little bit so I can change it, and just make sure I flex my delts while I'm doing so. Okay, if Sean wants to make my parabola thinner, what can he do? Okay, so two options. Just do one, I'll mirror the other. You can do both if you want to. Am I thinner? Now, I got steeper, right? Thinner, steeper. Okay, now he pushed me how? You pushed me up to do that? Okay, make me thinner without pushing me up. Just use this hand, and I'll just mirror it on this side. If he pushes in, directly in, it's going to squeeze this parabola together as well, right? So if I'm thinking about a parabola, thank you, Sean, for that. If I'm thinking about a parabola and I don't have a good way to model this, I really wish I did, other than what we've just done. If I have that, hate it. If I have, still hate it, but that's okay. If I have this parabola, regardless of where it is, if I push like this on it, what happens to everything else? It goes from this and it pushes inside and gets thinner, right? Okay, so apparently I can squeeze it from the outside horizontally. I can make it thinner another way though. Instead of pushing in there, what could I do? What if instead I grabbed on and I just pulled up? And I just pulled straight up, would that make it thinner? Now, in the grand scheme of things, if I just give you a parabola and said, hey, it's thinner than the normal one, did I push it in or pull it up? Can you really tell? Not particularly, and there's a reason for that with parabolas. The word thinner is a weird idea when we start thinking about other graphs. This graph, and I'm just going to draw one more. This graph, let's say it's a parent, or an original function that we then transform. Did this graph, compared to it, get thinner, or did it get steeper? One of them or both or something, right? There's some weird language stuff that happens with how do we interpret these things. Now, in any case, what we're going to be able to do, and I'm not going to destroy you guys, and I'm honestly not super concerned whether you can tell me exactly which one happened as long as you recognize one of them did. Graphically speaking, of course. So, we're going to look at some non-rigid transformations. First comment that we're going to make. If you were to think of a parabola, you push arms in or pull arms up, we change the actual shape of it, right? It's still a parabola, but its size and orientation might be different. So we're going to say distort, or these. See, again, I don't know why I look there. These distort. And then in parentheses, not change our shape. And immediately, I hate this language, but if we talk about it, I think we can clear it up. I would argue that making a distortion of a shape does change it. But here's what I mean. If you start with a parabola and you distort it, you end with a what? Parabola. We haven't actually changed the overall shape. We just changed how it's sitting. Okay. Now, of these, we're going to work with that same function f of x. And we're going to work with the value c, the same. Everything's all the same. So let's say that we have some function h, and I want to look at a couple of these. We have two specific situations, and I want to stay consistent. Do your notes look like this? We did the math part first and then said what it did. Okay. So notice so far what we've done. We have put a c value in the argument, adding it and subtracting it. We've also put a c value outside of the argument. And then in this case, it's kind of unique because there's no real c value. We're just putting the negative in the argument or outside of the argument. Now, there's one more place that c could go. In the argument or outside of the argument here as addition. We've hit addition, subtraction. What's the other side of the operation? Multiplication. So we have the following to discuss today. Let's say hypothetically, and these ones need to be spaced a little bit more, and we'll talk about why. But let's say we have our function h of x. And we started with some f, just like we did yesterday, and instead of putting plus c or minus c inside or outside of it, we have the option of doing this. Now, yesterday, and I'm going to make, there's something about that I don't like. I don't know what it is. I think the c was too small or big. C times f of x. Okay, for that thing, what happens? And follow-up or unrelated, similar question, related a little bit. What did we say yesterday about c? We know something about that number c. We require that it is in the set of, be more specific, which real numbers? The positives. A little bit less than half of them. Okay, why a little bit less than half of them? Why isn't the positive reals exactly half of them? 0. Cool. All right, so here I have a variety of graphs, and I want to use the right one. Close your eyes real quick so that if it's spoiled, I don't want to spoil it for you. Cool. All right, so here we have a lovely graph. Check it out, it's beautiful. I'm going to keep that parent up for now. I'm going to put some c number in front of this. So the cool thing about Desmos is, let's pick a c first. Give me any value c that's an r plus. If I do this, and I'm just going to try, if I say h of x is defined to be the function a times f of x, and it should start at 1, I hope it does. Cool, that's the function. Is that what, I can use c. Why wouldn't I use c? That's silly. All right, cf of x, so it looks the exact same. If c is 1, it's just the same function, right? Okay, I'm going to move c around, and we can do this two ways. Do you guys understand what the slider is doing as I use it? Okay, give me a number to be positive. Do you want me to get bigger than 1 or smaller than 1?
4.
Okay, so we're going to make it bigger. Real quickly, spend about 20 seconds reasoning it out. Try not to sketch it if you don't, I wouldn't sketch it. If I make c bigger than 1, how does that change the shape of my parabola? Does it get thinner or wider if c is bigger than 1? That's a question. Think it out. Talk to the neighbors. How much money do you have? How much money do you have? Sign up, okay? Just for the record, somebody took their phone yesterday when they went. Don't do that. Cool. All right. One hand if it gets thinner. 2 hands if it gets wider. Ooh, we're split. Love it. Okay, moment of truth. Here we go. I'm going to let c get larger. And c is a constant multiple on the front of this function. Thinner, 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 thinner. Now, don't be discouraged because there's some wonky stuff that happens. Now, as we look at it, I'm going to pause there, and we're going to make a comment. This thing has to break off into 2 different situations because we just let c be bigger than what number? Okay, so I'm actually going to break it into 3 situations to try to make this more clear. If c is 1, nothing changes. And just to show you, I will do this. The red function is my original. The black, quit it. The black one is the new one, and they're the same. Off or on, it's the same graph. Cool. One possibility, and I am okay with any of these. If I'm going to do c is greater than 1, should it go above it or below it? And I don't really care because we're going to do one's bigger than 1 and one's smaller. Up, okay. If c is greater than 1, which I think is the situation that we just looked at, c is greater than 1, what happened? The graph got thinner. Now, for this, and it's super weird to see this, if it gets thinner, I'll tell you, we're working in the vertical direction here. And again, it's not going to make a difference what the graph looks like. But if I want to make a parabola that I'm holding on to right here thinner, do I need to pull up or do I need to push down to make it thinner? Up. Okay, so I am going to use 2 words. You guys threw out the word dilation yesterday, which I love. I'm going to say this thing is a vertical, and 2 choices for us that we're going to use consistently. It's either going to stretch or it's going to compress. If I pulled upward on it, would it be stretching or compressing? Vertical stretch. Okay, now in parentheses, italic, whatever you want to do, your fancy cursive script, thinner is what we look at for a vertical stretch. Okay, I want you to tell me why the following statement isn't quite true. It's mostly true, and you can write it. Just make sure you leave space in between your symbols. The obvious other option is less than 1, right? Okay, what do you think is going to happen? I'll tell you first, it is going to be vertical. Your gut's probably going to be okay. Vertical. Is it going to be a stretch, a compression, or what if we get less than 1, do you think? Okay, check this. I'm going to pick a number less than 1. It's going to be wonky. Boom. Negative 4.8. Is that less than 1? It is. Can you tell me what happened? Is it wider or thinner? Oh, no. Wait, I thought if C was greater than 1, it was supposed to be thinner. But I just picked C as very far less than 1, and it's thinner. I'm misleading you very intentionally. What happened? Say it again. It reflected. Remember, we already have a C in front. We just hadn't really talked about it. It's this situation. We just had it reflect over the x-axis. Okay, so if I want to make sure that I don't do that, and I want to end between 0 and 1, there's 2 ways you can do it. The common way, and the way your book does it, don't write this unless you love it, 0 must be less than C must be less than 1. Or, because we're lazy and maybe write in pen, there's something I can change about this to fix it. Not or equal to. I'm just trying to make sure we don't get negatives. I'm absolutely certain you guys have seen this before. Absolute value. So the absolute value of C is greater than 1. And same thing here, we're going to add those absolute values up there. If it winds up being negative, you get the reflection, and then same, thinner or wider. So vertical, and I'll just get these values now. Let's pick something between 0 and 1. And here we are. Here's 1. Is it still parabola? Okay? And there's a weird thing that happens, but I'll say this is a vertical stretch or compression. If I'm holding a parabola, I'm going to push either up or down. I want it to be wider. Do I pull it up or do I push it down? I push down and I compress. Okay. So we have a vertical compression. Now that's the appropriate language. I have no issue with another word, thinner and wider. Especially for parabolas. Now it gets weird to think about if you have a cubic function that maybe thinner and wider don't make sense, because then what it's going to wind up impacting is, does it just get steep faster or slower, which is the same thing as what thin and wide does, just thin and wide is easier. There's one little value that C can't be. I'm not even going to write it down, but it makes everything kind of uninteresting. If C is 0, oh my gosh. Okay, you saw it, I imagine. For whatever reason, when I take my pen off, that's it. Is it a parabola anymore? It's the black line, the bold black line on the x-axis. No, it's just 0. It's a constant. Okay. Now, that was one option. I put C outside. I'm going to change it back to 1 so that nothing changes. What's the other option? Where else could I put C? Talk with your neighbors. There's a specific word I'm looking for, but I'll take just roundabout ideas. The other option, h of x. I want guesses. I don't care if they're wrong. I'm going to write f of x, and there's going to be C in it somewhere. Somewhere in that process. It's not going to be x plus C or x minus. I need my random number. Here it is. I think I heard it somewhere. Angel, yeah. Can you repeat that? Inside the what? I'm okay with that. Inside the parentheses, better language. Arg. Inside the argument. All right, so let's check it out. This time, we're going to compare f of cx. Now, fundamentally different thing, but we're going to see these same 3 options. If it's 1, nothing. Nothing changes, because that's still just whatever. No change. Okay. What if, though, just maybe from time to time, we let the absolute value of that C be greater than 1? And similarly, we'll let the absolute value of that C be less than 1. Notice again that I'm not even bothering to write the zero case. Doesn't matter. Absolute values, similar idea behind. Gut feeling? Go. Okay. Did Huggins come back? I thought I saw him here. Wasn't he here just a second ago, Sean? Okay, if you see Huggins, tell him to check in. That would explain it. But I just looked down and he was gone. Okay. If C is bigger than 1, what do you think will happen? Thinner or wider? And I'll tell you, just for the record, before we were pulling up and down. Now it's like I'm grabbing it in some direction. I can pull them in towards me and it makes it steeper or thinner. In the other direction, it's like I push out and it makes it wider. So it's a very similar look, like exact same look. But let's just check. Total shot in the dark. It might be if I let C live right there. If I make it bigger, what happens? Thinner or wider? Thinner is 1 arm, wider is 2. Total guess I'm fine with. What's your gut say? C is greater than 1 is thinner for most of you. Okay, let's check. Okay, it did. Cool. As we look at this, we are now squeezing this thing horizontally. Now, there's a weird little way that we can word this, and your book uses stretch and shrink, but that always confuses the heck out of me. Because stretching and compressing, I think, are opposite. Stretch and shrink, it just depends. So let's take a look. If we look at this, we got wider, I think, right? So f of, make sure it's the right C value. We'll try B just to make sure it does the same thing. Bx, yep, it does get thinner. Okay, I'm comfortable with that. I'll go back to C. How would you call that? Did we horizontally stretch or compress? We compressed, right? Now notice what's really weird about this. Before, vertically, C is less than 1 makes it compress. Horizontally, however, C is greater than 1 makes it compress. There's a weird little change here that has always bugged me. Can I just say horiz? Good, that's what I'm going to say. Compression. Now, here's the other part, weird part. Wider or thinner? It was thinner. So in one sense, compressions make it wider, but in the other, it makes it thinner. With our powers of deduction and induction, what's going to happen if I let C be between 0 and 1? It'll be a horizontal stretch. And it will be wider. And I'll verify that here in just a second. They use stretch and shrink. I don't like the language because it just doesn't sit right with me. If you want to make that switch, you can. I'm fine with it. Okay, let's check that just to verify. If I let this value, now that C is on the inside, yep, it does exactly what we thought. Okay, need to go? All right. Cool. How's this feeling? All right, I have a challenge for you. Somewhere, we'll find it. I want you guys, you don't have to graph it yet, we will. Here's a function, and I'm going to pick something more interesting than that. I do not want you to do all the multiplication and stuff. I'm going to say we have x cubed. F of x is equal to x cubed plus x. I want you guys to find me h of x such that the graph, in no particular order right now at least, is shifted right to horizontally compressed to be half as wide. So that's compressed by a factor of 2. There's a weird language there. Reflected over the x-axis and shifted up 5. Should we, I don't want us to graph it, we'll graph it together. I want you guys right now, and I know this is a big ask currently, try to write me my function h of x, and I lied, I want it in this order. I want it to first shift, and then to compress, and then reflect, and then move up 5. In this order. Try your best, we're gonna check a few of them. I will write h of x right here. Your job is, as your table, your groups, whatever you want to call yourselves, I want you to do these things in this order. Cool, try it out. I'm gonna put the graph up on the board as well here in just a minute, and then we'll actually just start playing with it. Cool. Yes. Now I'm actually just going to show you this. That way you can move through it. If it's inside and C is bigger than 1, it's a horizontal. Okay. That's just, all right. And do you guys have these ones written down so I can? Now, what happens? Check, we did that, good. To make it half as wide, this is a weird idea. Half as wide is compressing it by a factor of 2, and this is going to be the one weird part that shows up. If you want to horizontally compress it to be half as wide or by a factor of 2, and that's strange language, sorry, where does the 2 go? Inside or outside? So, inside my argument? Now, if we do this, something weird that we have to be willing to deal with. Now, horizontally compressed, did that graph get thinner? And it's a weird thing, but all of a sudden, what I want to think about is, did I move too far? Now, what I mean by that is if we put these 2's here, what I'm concerned about, and I'm not really concerned about it, to be honest, having this number inside makes it harder to deal with. Pretty common, and I'm not going to make you guys do it right now, but if I were working this problem myself and I had to show all my steps, I would probably do this. Just to make sure that I could see that, oh yeah, there's a 2 in front of the x, because sometimes it'll be wonky and it'll be hard to pick out how far to the right or left have you moved. Now, as it turns out, this thing will do the same piece, right? Like it's the exact same expression. I factored out the 2. Okay, so just hopefully that didn't confuse you. If you don't have any idea what I'm talking about there, that's fine. All right, we did it. It's thinner. Now what happens? How do I reflect this thing over the x-axis? Make it negative. Now, I'm going to just take a step up, and I can just do it here. We've already taken care of those 2 pieces. Why am I putting parentheses around these? Because the whole thing needs to flip. Now, you can't see it happen, but my whole graph has just rotated completely over the x-axis. Everything is flipped. If I undo it, notice this point that lives at 3, 2, or rather 1.52. I just can't get it. When we flip it, 1.5, negative 2, and I see it's reflected. All right, the last step, to make this thing now go up 5, what do? Plus 5. Now, this is what I was referring to earlier when it really matters which one happens first. And we'll look at the order of operations, see which one really would, because there's some ambiguity that's needed. Is this the answer that you have? Anybody have this exactly? So let's check. No, like I want wrong answers. Hit it. Somebody came up with one that wasn't this, and I'm gonna work through that. I'll write the final one up here eventually. Let me know what you did. Give me some answers. Something. I can also just take your notebook if you don't want to read it. Ralph, what do you have written down? So like this? Essentially? Okay. Anybody else do the same thing? To be half as wide, it's a weird idea. That's strange. Other mistakes? Everybody just kind of got through the first part and maybe didn't finish, and that's why I'm not getting answers? You were in the bathroom, so that makes sense that you don't have one. Cool. We just keep making eye contact, so like I'm not expecting an answer there. All right. Should we try another one? Okay. So this time, I'm going to put this answer here, though. This annoys me, just so you know. When I write this, if I want it reflected like that, I would see that I'm going to reflect eventually. Negative, let's see, factor of 2, 2x minus, what would it have to be here? Not anymore, because if I do that, what spits out? It has to be a 1 so that I get the other answer in there. So Control Z, 1, and then I would distribute to get that 2x minus 2 part. Cubed minus 2 times x minus 1, and that extra parentheses, annoying, plus 5. That's how I would write this answer. It looks a little bit different, but is it? What's the only thing that I've done? I factored out the 2 and I distributed this negative. Okay, there's going to be a bunch of possible answers. If you guys are reading answers on like a quiz or a test and you give them, I'll take the time to go through and see if your work makes sense. Step by step is really helpful for that. I showed it on the Desmos, not here. All right. This is one direction. Do you want to go the same direction with your neighbors, or do you want to try to flip it? And like I give you a graph and a second graph, and now you have to tell me what happened. That's harder, because you can never tell for sure if I've horizontally compressed or not. Okay. So everybody, this is going to be a controversial question, and I don't want it to cause like arguments or anything but like that. But I'm going to pick one random person to answer this. There's not that many people. Number 10. Who's number 10? Riley, what's your favorite polynomial function? Okay, that's what I was expecting. What's a polynomial function? Integer powers. So check it out. I have no idea what this graph will look like. 2x to the 4th plus x cubed minus 1. Okay. I want us to do the following. And we're just going to use some transformations that I want them to happen in a specific order. Or I just want all these things to happen. Yeah, we'll just do that. What's the first thing you want to happen? We're shifting it somehow. Which way? Say it again? Down 1. Okay. So I'm going to save that for down here, and I'm doing this particular reason. Down 1. Got it. We're going to reflect or not? Let's reflect, but this time we're going to switch it up. Let's reflect over y-axis. And I know it's wonky because I'm going backward. Let's vertically stretch this thing by factor of 3. And then let's shift. We went right 2 before. Let's shift left 1/2 units. I want you guys to find the h that takes this function f and does that. Cool, cool, cool. I'm going to give you guys a couple minutes. Talk it out with one another. I will pause this. I will get the original graph, and then we'll just throw in some stuff up here. Sweet. Okay, so for step alpha, our first step here, does that follow the rules that we used? Okay, then what happens? Okay, if I want it to be a vertical stretch, that's me making it thinner, right? So what values of 3 should I make? Like, where should I put it? Inside or outside if it's a vertical stretch? Outside, and let's just double check. I want it to be vertically stretched outside. Okay, so what should I put outside of it? A 3, by a factor of 3. And I should have changed the language on the other one. That was my bad. So it is going to be 3 times steeper, or get faster 3 times faster. Sorry, get steeper 3 times faster, or thinner 3 times thinner. And it's a weird idea to work that out. But it's okay. We don't care about the idea necessarily because we're not the ones graphing it. So 3 goes out front, right? Everything in here is my function f. So it's just like I do, okay, 3 of that, and I'll just write h of x, and I'm going to take bigger steps here. 3, and then all of that just gets copied. Literally the entire function just got multiplied by 3, and it's now thinner. 3 times thinner. Or 1/3 as wide is where that gets strange. Do you guys agree with that statement? Have I lost anybody yet? Okay. How do I reflect this thing over the y-axis? Anywhere that there was an x, and this is where it gets wonky, I put the negative in front of the argument, right? Inside the argument. which means love these, I don't want to word this, love these parentheses, I guess. So here we go. If I just do this, and I'll do it in blue so we can tell it, does this do the trick if I just do that? What do you guys think? Let's check. So we'll have this function. Can somebody read me what we just had? 3 times, gross. 3 times what? 2 times x to the power of 3? 4, thank you. Plus the power of 3 minus 1. Okay. Why don't you like this? Cannot index a number with a number. Where did I index a number with a number? Okay, so we're just going to use this example real quick. I'll just Control Z everything that we had. So it was okay with it for a minute. Still didn't like it, still doesn't like it. Still doesn't like it. What are you doing? Alright, I want to try this one real quick. Here's this one. It's all fine and dandy. We haven't shifted it up 5 yet. I just want to see what happens. If I'm trying to reflect it over the y-axis, if I just put a negative here and a negative here, did it do it? And I should probably copy and paste so we can actually see the original as well. That's where we started. We'll copy that guy. If we just stick a negative there, and a negative right here. That work? Awesome. Rather good gut feeling. You're good. Okay, so we'll sneak our negatives in. That's step gamma. I'm just going to stick, I don't like that green color. Gamma. I would change something else. And you guys need to tell me if this is like way too much. I want to call this 6. And then we can work it out in here. Negative x plus 1/2 to the 4th. Plus 3 negative x plus 1/2 to the 3rd. Minus 3. Can you guys tell me what I've done? I distributed that 3 that was in the very front that we used as our vertical stretch. All right.
Why is there a 3 in front of the middle?
Because when we distribute, it winds up being 3 times 2 times this whole term. And then we distribute that 3 to the 1 that's up front here. And then it also distributes to this one here. Okay, one more step. Down 1, I'm just going to use this line. What do I need to add? I could put brackets around everything and say minus 1. But if I just subtract 1 from that, will I get, what would it be, minus what in the end? So yeah, we'll just do the whole same thing. We'll just minus 1 more and make it minus 4. All right, this stuff, when we're working them together, I imagine it feels okay. If I ask you to do a big problem like that alone, is it as easy? Probably not. Is that okay? It's going to happen that way in math like all the time. Math feels easy in the classroom, and it feels like god-awful at home. It happens. I understand it. So, looking at stuff. I want you guys to try one little problem set this evening. Maybe. Can I have my notes back from you, Huggins? I'm going to take these. Don't. We have 5 minutes left, right? No, you're good. I don't love the idea of just making you guys graph and graph and graph and graph and graph and graph. I don't think that's fun. So, here's what I want you guys to do. We're going to pick easy problems. Yo!
Why did the 3 distribute to the negative 1 to negative 4?
Because I was getting real lazy with my writing. My last step is a shift of down 1, right? So it's like, here's my original thing, and then we add or subtract at the very end of it to make our shift down or up. These parentheses don't really do anything for the whole up expression, and I just add them together. Because I'm terrible about writing everything. Thank you for asking. Okay, so let's see here. The homework that I've given in the past, Don't love that problem. All right. You get homework 1.7. It's going to be short, I promise. Which will start on page 72. You get the privilege of problems 1 through 4. And 15 through 20. And that might be it, but let me double check. I'm okay with those for now. 1 through 4 and 15 through 20. 9 problems. Baller. Tomorrow we get some fog in Goth.
What?
We're composing functions. That joke will land tomorrow. It's not really a joke.